In the following video, we're going to use matrices to create equations and solve. So there's two examples we're going to look at. The first example, we have 40 plus 2y in the first matrix. 5 minus 4x is equal to the matrix 2x, y. Now, the reason why this one's a little bit tricky for students to understand is because remember, matrices are labeled rows by columns. And so if you ask us, ask students how many rows and how many columns, they'll get it right. There's 2 rows here. But then if you ask them, well, how many columns are there? A lot of students want to say there's 2 columns because they see the 40 and the 2y. But really, there's only 1 column. And the reason why is because this 40 plus 2y is an expression. If you look at, say, this example, you see the columns are separated by a space, a blank area, no operation or anything. So really this is 1 column, and this is a 2 by 1, 2 rows, 1 column. That's why we can say the matrices are equal. And so to set up the equations, what you do is you set each row equal to each row, each location equal to each location. So, this is, row 1, column 1. You're going to want to set it equal to row 1, column 1 in the other matrix. So you have 40 plus 2y is equal to 2x. And we could say the same thing about the 5 minus 4x is equal to the same position, which is y in the other matrix. So then 5 minus 4x equals y. And so we created an equation from our matrices. We actually created a system of equations. We have 2 equations and 2 variables. So we can either solve this using substitution or using elimination. And so what I'm going to do is I'm going to use substitution. And the reason why is because I see in the second equation y is equal to 5 minus 4x. And so what I'm going to do is I'm going to plug this in for y in the other equation. So I have 40 plus 2y, but instead of y, I'm going to put 5 minus 4x in parentheses equals 2x. You're going to distribute first to get 10 minus 8x equals 2x. When you combine like terms, 40 plus 10 is 50. And you're going to, so you would add the 8x to the other side. And so you have 2x plus 8x will give you 10x. Solve, divide both sides by 10, x equals 5. And so now that you know x equals 5, we can plug it in and solve for y. So y equals 5 minus 4x. 5 minus 4 times 5. 5 minus 20 is negative 15. And so when we write our equations, in this one we saw by doing that we had 2 separate equations with 2 unknown variables. And so we're going to have to use our systems of equations approach to solve it. And remember, you base it off, set up the equations by location. This is row 1, column 1, and so you're going to set it equal to row 1, column 1. This is row 2, column 1, so you're going to set it equal to row 2, column 1. And so let's use that idea and that understanding to help us with the next example. This one may be a little bit easier because if you look, we can see, and I'll label it so we know how to set it up. I see 2 rows and 2 columns in the first matrix, so it's a 2 by 2 matrix. 2 rows and 2 columns in the second matrix. And so I can say they're equal because they have the same dimensions. And so what we're going to do is set, here's row 1, column 1, x. We're going to set it equal to row 1, column 1, which is 2. And so we don't even have to solve. X is already solved for. I'm told x equals 2 by just setting the matrices equal based off position. So let's try the next one. And so if I see y is in row 2, column 1. So in the next matrix, I have my y. Here's row 2 down here, and here's column 1 in row 2. So y is equal to -1. So there is no solvent for y. It's already there. It says y equals -1. And the last one is going to be z. Z is in row 2, column 2. And so the next matrix, I'm going to go row 2, column 2, and I see that z equals 1. There is no solving for this. All my variables are equal to numbers. I don't have to, but for the number 3, when I set it up, I saw by setting up rows, row 1 equal to row 1, row 1, column 1 equal to row 1, column 1, I had still 2 variables, and I had 2 separate equations of 2 variables, so I have to remember that means I have a system, and I'm going to use substitution or elimination to solve from there. So to solve matrix equations, to set up a matrix equation and solve, what you do is set positions equal to positions. Set the location equal to the location. And then if you have to, solve from there, either by doing elimination or substitution or solving an equation. If it's just as simple as the variables equal number, then you're all set.